Welcome to today's Explainer, everyone. We are diving deep into an absolutely critical area of the Cambridge AS and A-Level Mathematics syllabus, subject code 9709, specifically topic 3.6, numerical solution of equations. Now, I want you to think about how you usually approach complex math problems. Do you just start writing and hope for the best? Today, we are going to completely flip that script. We're going to explore a high-performance exam strategy that I like to call the weightlifter. Think about a professional weightlifter. They don't just walk up to the bar and tug at it randomly for an hour. No way. They step up, they establish perfect form, and they apply massive, concentrated, explosive effort in a very short burst to lift something incredibly heavy. High-mark Cambridge questions require that exact same explosive power. Rather than a marathon of endless, unfocused calculation, this approach is all about efficiency, precision, and perfect form. To secure those high method marks, you literally cannot afford to coast or rely on messy scratchpad calculations. You need to step up, deconstruct the equation, and execute with maximum effort. Let's get right into it.
To really set the stage for why this matters, I want to share something eye-opening. A senior examiner recently noted that the difference between a B and an A star in mathematics often comes down to how well you understand 3.6, numerical solution of equations. Think about that for a second. This single topic, which, by the way, shares deep foundational concepts with topic 2.6 and some syllabus variations, is essentially a gatekeeper. It is standing between you and the top grades. Why? Because examiners use this specific topic to aggressively test your stamina and precision. They are actively looking for candidates who can handle complex numerical methods without losing their way in a sea of decimals. Mastering the logical flow here, knowing exactly how to demonstrate convergence or prove a root lies within a specific interval, signals to the examiner that you are a top-tier candidate. It proves you don't just memorize formulas, you actually understand mathematical behavior.
So, here is our playbook for today's session. First, we'll outline the challenge. Second, we'll dive into the core principles and the strategy reveal. Third, we'll walk through the transformation of an actual answer. Fourth, we're doing a high-pressure interactive workshop. And finally, we will lock it all in with our final mastery system.
Let's kick things off with Section 1, the challenge, pitfall to peak. We need to look at the exact traps that catch even the most dedicated, hard-working students year after year.
To illustrate this, let's look at two student personas tackling a real Cambridge past paper question from code 0580. Meet Alex and Sam. Now, Alex is that student we all know, incredibly hardworking, but overloads the page with raw math facts. Alex's exam paper looks like a chaotic spreadsheet. It's just endless, unformatted numbers, x1, x2, x3, sprawling everywhere with zero annotations. It's a mile wide and an inch deep. Alex offers superficial breadth, but absolutely no analysis, leading to totally unnecessary lost marks because the logical structure is completely missing. Then, over on the other side, we have Sam. Sam is the speedster. Sam sees a numerical equation and just wants to get to the finish line. Sam rushes straight to the final decimal answer, completely misses the command word requirements, ignores the context of the question, and totally bypasses vital terminology. Sam's calculator might show the right number, but the examiner's mark scheme shows a 0. Why? Because both approaches entirely fail the core demand for structured reasoning. They might be doing the math, but they are categorically failing to answer the exam question the way Cambridge demands.
That brings us perfectly to Section 2, Core Principles and Strategy, the Strategy Reveal. It's time to pull back the curtain and decode the actual assessment objectives that the examiners use to grade your paper.
The Cambridge Examiner's Assessment Framework targets 3 distinct cognitive domains, and you need to understand the difference between them. The first is knowledge and understanding. This is the absolute baseline, knowing the iterative formula and understanding what an iteration actually is. The second domain is application. This means executing the mathematical operation accurately, like physically typing the numbers into your calculator without making a mistake. But here is the secret. The third domain, analysis, is where the A-star marks live. The assessment framework aggressively prioritizes analytical depth over superficial breadth. To achieve top marks, you must prove to the examiner that you understand why the numerical method works. Why does a sign change indicate a root? Why is this specific sequence converging? If you are only operating in the knowledge and application domains, you are leaving massive points on the table.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, let's look at the ultimate strategy framework that forces you into that analysis domain. Deconstruct, solve, and evaluate. But we're going to supercharge this by layering it with the PEEL framework. Point, evidence, explanation, link. First, you deconstruct. You break down the complex text and command words into logical steps. Second, you solve systematically. You lay out your iterations with extreme clarity. Third, and most importantly, you evaluate using PEEL. You make your point about where the root lies. You provide evidence by showing the calculated iterations. You offer an explanation of the sign change, and you link it all back to the original context of the question. Think of it as your iterative proof framework. This practically forces the examiner to award you top marks.
Let's do a quick mental check right now. I'm putting 30 seconds on the clock in your mind. Think back to Alex and Sam. Which student approach actually applies this systematic analysis and evidence-based reasoning? Is it the one writing down 50 lines of unannotated numbers, crossing their fingers, and hoping the examiner spots the right decimal value hidden in the mess? Or is it the student who sets up a clear, structured table, calculates the exact required iterations, explicitly shows the sign change, and uses the PEEL framework to confidently conclude that a root lies within a specific interval? It's clearly the latter, right? This highly structured approach aggressively targets those higher-order cognitive domains. It literally builds a bridge, leading the examiner directly to your method marks.
Let's move into Section 3, the transformation. We are going to look at what I call the method mark strategy, because in Cambridge Mathematics, the process is just as powerful as the final answer.
Look at this comparison. On the left, we have a raw dump of unannotated numbers. This is a failing setup. An examiner looking at this has absolutely no idea if you actually understand the mathematical process or if you just accidentally press the right buttons on your calculator. It's a mess of red pen marks waiting to happen. Now compare that to the A-star response on the right. Notice the strict conventions. We're talking proper headings for every single iteration, correct mathematical terminology, and crystal clear annotation. Developing these practical presentation skills proves your analytical depth. It shows you are in total control of the data. And here's the best part. Even if your final decimal place is slightly off due to a silly rounding error under exam pressure, a rigorous, perfectly formatted setup secures the vast majority of the method marks anyway. Process is power.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Now, pay very close attention to this massive red warning pulled straight from the Principal Examiner Reports for Topic 3.6. Examiner alert. Candidates consistently confuse key terminology. You must be incredibly precise with your language in extended responses. You absolutely cannot afford to lose easy marks because you used the word equation when you actually meant expression, or because you wrote that a sequence converges when the math clearly shows it diverges. The procedural framework for numerical solutions demands appropriate terminology and correct formatting. You have to communicate like a mathematician, not just a human calculator.
All right, it is time to put everything we've talked about to the test. Welcome to Section 4, the interactive workshop. We are going to apply maximum effort in short bursts, just like a weightlifter. Let's go.
Challenge 1 is the data scan. Imagine a 60-second timer ticking down on your screen right now. You are presented with this highly complex numerical table filled with iterations, equations, and uncontextualized variables. Now, your job is not to read every single number. That's a trap. Your job, under intense time pressure, is to extract the core trend. Look at the sequence of values. As the iterations increase, x1, x2, x3, all the way to x6, are the numerical values oscillating, or are they converging toward a specific root? Data interpretation skills are absolutely critical here. You must extract the underlying mathematical relationships and prepare to draw evidence-based conclusions. If you just see a bunch of random decimals floating on the page, you're missing the big picture. You need to train your eyes to look for the trend, to spot the convergence, not just get lost in individual data points.
Let's move to Challenge 2, Find the Flaw. I want you to read through this sample student paragraph. On the surface, it looks okay. The variables are identified perfectly, the numbers are plugged into the iterative formula without any calculation errors. But here's the catch. It fails to state any assumptions, and it provides no alternative interpretations or context. Take a few seconds and pinpoint exactly why this descriptive response is going to lose marks. Got it? The reason is that higher-order assessment objectives demand evaluation, remember.
This answer is completely stuck at the basic descriptive level. It hasn't reached the analytical depth required by the command words. It's literally just reciting numbers back to the examiner without proving any understanding of the numerical method's limitations.
Let's look at the fix. On the left, that raw solution without context earns minimal method marks at best. But on the right, look at the A-star response. The real points are awarded for a justified recommendation that actually addresses the limitations of the numerical method. A truly strong response explicitly states the assumptions made during calculation, like assuming the function is continuous within the given interval. Evaluating the quality of your evidence requires you to identify these limitations and explain their effect on your final conclusions. You aren't just doing math here, you are actively critiquing your own mathematical process. That is exactly what transforms a B grade into an A-star grade.
Challenge 3 is speed writing. I am giving you exactly 30 seconds, counting down right now. I want you to mentally draft one perfect PEL paragraph. State the interval for your point, reference the sign change for your evidence, explicitly explain how that proves the root for your explanation, and link it all together. Go! Calculate the values in your head, compare the results to find that crucial sign change from positive to negative, and confidently conclude your bounds. 5 seconds left. And time. I know that was fast, but structuring your thoughts that quickly, clearly, and under intense pressure is exactly what ensures you are unshakable in the real exam hall.
Excellent work in the workshop. Now let's bring it all together in Section 5, the final mastery system. We're going to break down the non-negotiable rules for securing top marks.
Based directly on the principal examiner reports, here are the top 3 warnings, the most costly mistakes that ruin grades every single year. Warning number 1, forgetting proper format. Writing a jumbled mess of numbers instead of a clean, tabular structure. Warning number 2, failing to check presentation. Simple rounding errors or misaligned decimal points that cascade into massive mistakes. And warning number 3, the biggest one. Answers not specific to context. If a question asks you to use numerical methods to find the depth of water in a reservoir, and your final, unannotated sentence is just x equals 4.5, you have completely failed to link your mathematical solution back to the real-world context of the exam prompt. Do not let scattered iterations or poor annotations cost you these easy, totally avoidable lost marks.
So here is your complete, bulletproof 3-rule answering system. Rule 1. Decode the command words and domains. You need to instantly recognize whether the question is testing your baseline knowledge, your application skills, or your deep analytical reasoning. Rule 2. Apply the deconstruct, solve, evaluate framework using the PEEL method. Identify the given info, solve it systematically step by step, and evaluate your findings with a justified conclusion. And Rule 3. Follow strict format conventions. This means setting up a time management matrix in your head. Ensure you leave enough time at the end of the paper to present your information with proper headings, correct terminology, and clear, undeniable annotations.
And listen, the results of this system absolutely speak for themselves. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries. That is massive. It's the difference between a C and an A. But here is the reality check. That improvement only happens if they practice these techniques consistently with our weekly videos. Process is power, but power requires training. By fully internalizing these strategies, you transition from simply attempting the math to totally mastering the exam. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. I'm going to leave you with this final provocative thought. The next time you sit down with a past paper to solve a complex numerical equation, I want you to stop, look at your page, and ask yourself honestly, are you truly evaluating your evidence, defining your terms clearly, and formatting your work perfectly to lock in every single method mark? If you use the weightlifter strategy, you won't just solve the equation, you will completely master the exam. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.